Hi everybody, this is going to be our note for 5.3, the sine law and acute triangles. So in 5.2, we examined triangles that were like, well, that didn't have a right angle in them, something like this. There are no right angles in here. So what we learned last lesson was, well, if I make a line going down, I can make a right triangle into that triangle so that I can work out calculations. But there's another way to do that. That way I don't have to do all that extra work. And that is with the sine law. So in any acute triangle, meaning one without a 90-degree angle, and all of the angles are less than 90 degrees, the ratios of each side to the sine of its opposite angle are equal. And it's represented by this formula. So meaning if I have letter A, B, and C here, these are angles, angle A, angle B, angle C. And across from them are the same letters just in lowercase. What we're saying here is the ratio, and these are saying the same thing. We'll also start with the sides being on the top. We're just saying the ratio of the side A divided by sine angle of A that it's opposite to. This ratio is the same ratio for B and for C for their sides and their angles. And it's same for the reciprocal. Reciprocal just means flip it. So if I flip all of these fractions and put the angles on the top and the sides on the bottom, well then it's the same thing, the ratios of like sine angle B divided by B, this ratio of the angle and its opposite side will be the same for all of these as well. So as long as we can label our triangle correctly, and as long as we can substitute the correct values into the equation, then we should be able to do sine law, hopefully pretty easily. Now another thing to note is that when we're using sine law, either the top one or the bottom one, and we'll see which one we're going to use when. To be honest, if we want to solve for the side, I usually like the side on the top of the fraction. And if I'm solving for the angle, I want the angle at the top of the fraction. But whenever I'm using sine law, I only ever want to use two ratios at a time. Never use all three sides of the formula at one time. For example, if we have a triangle, let's just use this one again, the one that we used up here. Let's just draw this again. If I have this triangle, again, no right angles, all the angles are less than 90, sorry. So if I have A, B, and C here. Now, if I were to set up my sine law, let's say I have this. Actually, you know what? I'm gonna, when you're doing the sine law, if you don't want to put that angle symbol in there, that's okay. Because sometimes people, when I write it, it looks like an L or something, and people will mistake it for something else. So as long as we know that capital is the angle and lowercase is the side. So if I'm doing this, and let's say I have to figure out what A is going to be. So let's say we don't know what A is. And I know sine A is a value, like we know the angle. Let's say it's, I don't know, 50 degrees. If I know either one of these, let's say if I knew the ratio of this and the ratio of this, and let's say that this just happens to equal 4, well, that means that this would also equal 4. So if both ratios equal the same thing, well, I don't need to use both of them to calculate this. In this case, I would just pick the one I don't know and one of these that I do know. Sometimes I'll only know one of them. Sometimes I might know both of them. But either case, I'm just going to choose one of the two. Because again, they're going to equal the same thing anyway. So in this case, maybe I just want to choose these two because they're beside each other. So let's pretend now that these weren't the same ratio. Let's say this was still, let's say we knew this ratio for B. Let's say this is going to be 4 over sine 75, let's say. When I'm picking apart these two ratios that I've chosen, we're going to say this is question mark because I still don't know what this is. We could put a variable in there like x or y, or just keep it as a. But when I get a question involving sine law, we must have either two sides and an angle opposite to a known side, sorry, or two angles in any side, which is the two scenarios we're going to come across. But what this really means is when I have these two ratios, I'm always going to have three things and not a fourth thing. So in this case, it's a side. I don't know what this side is, so I'm going to have two angles and a side in this case, and I want to solve for a side. Let's say another example where I have, let's say, I'm solving for sine angle C, but I know side C is, I don't know, 10, and I know these two other measurements maybe. Here I'm trying to solve for an angle, and I know two sides and an angle. So whenever I'm solving for any of these using sine law, I'm always going to have three numbers, and then I always have to solve for another one when I'm using sine law. So let's get to an example. It says, for example 1, it says in triangle ABC, side A is 10 centimeters long, side B is 12 centimeters long, and angle A measures 35 degrees. Determine the measure of angle B. Always, 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 we should draw a diagram. And if you're like, I can't draw a diagram, just have to draw a triangle. If you're like, I can't draw a triangle, you just have to draw 3 lines. Don't even use a ruler, it's fine. Make it larger so you can read the numbers easier. Don't make it really cramped so it's hard to read. So we have a triangle with vertices A, B, and C, or vertices A, B, and C. So A, B, and C. So angles A, B, and C, we use capital letters. It says side A with a lowercase a is 10 centimeters long, which means this is across from A. Lowercase a is 10 centimeters long. Across from angle A is side A, so 10 centimeters. Side B, which is opposite angle B, because it's lowercase, is 12 centimeters long. Angle A measures 35 degrees, and it says determine the measure of angle B. So I'm just going to show my mindset for doing this. We can skip some steps later on, but let's just see how we would kind of approach this question. So what do we need to solve for here? It says we need to find the measure of angle B. So angle B is what we're trying to solve for. So since I'm trying to solve for an angle, out of my two sine law equations, I said if I want to solve for an angle, it's much easier to have the angle on the top of the fraction. So I'm going to use the sine law where the angles are on the top. So I'm going to write sine of angle A over A, sine of angle B over lowercase b, and sine of angle C over lowercase c. So I need to solve for angle B. So what other information do I have? Well, how about, do I have an angle A? Oh, we actually know that's 35 degrees. That's what it says in the question. That's what I have in my diagram. Angle A is 35 degrees. Is there an angle C? No, we don't know what that is either. How about side B? Because we're going BAC. Let's go BAC here. Side B is 12 centimeters. Side A is 10 centimeters. And side C, we don't know. So how did I get this information? It's in the question. I also drew a diagram just so I can visualize what we have. So I can already kind of see here, I don't have side C, I don't have angle C. I don't think I'm going to be using this one out of the 3 that I have. Remember, I'm just going to choose 2 of them. And the fact that I have angle A and side A, like I have these 2 measurements, means I have this ratio filled out, and I have side B, but not angle B. Which means when I put these numbers in, let's just fill in sine A. Angle A is 35 degrees. Side A is 10. Sine B, angle B is what we're looking for based on the question. All over side B, which is 12. So now we have 3 things. I have an angle and 2 sides. I can solve for the 4th thing, in this case, which is the angle, which is what we want here. So all I'm going to do is isolate for sine B. So first thing I'm going to do, I see a fraction. multiply both sides by the denominator. We're going to be left with sine b is equal to, I'm just going to do it like this, 12 times sine 35 all over 10. You're probably wondering, why am I writing it like that? Well, if I'm solving for an angle here, when we did our primary trig ratios, I need to get rid of the sine here. So we're actually going to do the inverse of sine here. And what you can do is you can make this a big decimal, but to get the most accurate answer, what you can do on your scientific calculator is you can input this one step at a time so we don't have to round off the decimal. So how can we do that? I'm going to show you on my calculator right now. So I just had to find the calculator. So I'm trying to write this into the calculator. So what I would do is I would kind of do BEDMAS working outwards. And I have a button that lets me put in my last answer into the calculator. So what I have to do is I see the button that says ANS, that means answer, and that's a green button. So for me, I have to press this alpha button. It's kind of like our second function button, but for our alpha button, I press that and I can access my answer. So everyone's calculator is a little bit different. If you want to turn this to a decimal and then use the sine -1 function, then you can do that too. So let's do sine 35, and I'll get a big decimal. I'm going to times that by 12. I get that number. I'm going to divide it by 10, and I get this number. So again, I'm doing all of this just so I can keep all these decimals. You can round it. I would suggest rounding it to 4 decimal places, so you get like 0.6883 in this case. You should get about the same answer, but the more decimals we leave, the better. So then once I do my second function sine to get the sine -1, I'm going to put my last answer in by doing that alpha answer. And then I'll press equals, and I get my angle to be 43.5 degrees. So what I'll do now is I'll show you. Why don't I just turn this into a decimal over here? So we have sine -1, and I did sine 35 times 12 divided by 10. If I just do this for 0.6883, I am going to get 6883, again 43.5 degrees. So you can just do this on your calculator, or I would go 4 decimal places and then do the sine -1. That way we get a more accurate answer for our angle. But that's it for this question. We found what angle, the measure of angle B is. We just have to write a therefore statement. Therefore, angle B is 43.5 degrees. All right, example 2. So we're going to start seeing that sometimes I have to use my sine law more than once to get more information. So we're going to see that in this question. It says in triangle XYZ, side Y is 8 centimeters long, side Z is 5 centimeters long, and angle Y measures 75 degrees. Determine the length of side X. So what do we start with? Always a diagram. And you're going to notice all my diagrams look the same because these are not drawn to scale. They don't have to look proper. I mean, it'd be good if they were proportional, like, you know, one angle's bigger than another if we know the angle measures, but most of my triangles just look like that. And I'm going to have X, Y, and Z. So it says side Y is 8 centimeters long. Angle Y opposite from that is side Y. Side Z is 5 centimeters long. And angle Y measures 75 degrees. Determine the side length of X. So diagram's done. So let's write down what do we know from the question. Well, I know angle Y is 75 degrees. I know angle Z right now is something I don't know. And I know angle X is also something I don't know. So I know that I don't know what these values are. How about side Y is 8 centimeters and side Z is 5 centimeters. And side x we don't know, but this is the one I want to find, because that's what the question asks me, is side of the length of side x. So I got to find the length of x. So we don't have angle x though to help us. That's what we kind of did last question we saw. Well, if I had a side and an angle in its opposite side, and then if I had one of these two, I could find the other one. But I need to find the angle of x here. So because I don't have this information though, maybe there's another piece of information I can figure out. Well, I do have z is equal to 5 centimeters, and I don't know what the angle of z is. So you know what? Let's write out our ratios. We have sine y over y, sine x over x, sine z over z. So these are my ratios, and I have the y's. I could write that in if I wanted to. Over 8. I don't know the x's, but I do know the sine length of z. So let's not use the x this time. Let's just use z here. We said sine length of z is 5, and then sine z is something I don't know. So even though we don't know this angle, we can still do other things in the question. Don't think that because we can't get this directly that we're out of options. Just like in real life problems, sometimes our most direct way to get to the answer isn't the right way. So let's find another way to get there. So in this case, we're going to find angle z. Well, why do I want to know what angle z is? Well, if I figure out what angle z is here, and I know this angle, well, I should know that these two angles, well, these three angles should add up to 180. So what I can do is 180 minus these two will give me angle x. So we got to find angle z to figure out what angle x is going to be. So luckily I know these three things, and I can figure out this fourth thing. And luckily I'm trying to find an angle, so I put an angle, the angles on the top of our ratios. So let's just solve for z now. I'm going to multiply both sides by 5. 8 is equal to sine z. And then I'm just going to do the sine -1 of this. 5 times sine 75 over 8. Again, you can just use a decimal to 4 decimal places. And that should be about exact enough. And then when I solve for angle z, I'm going to get 37.14 degrees. And if you want, you can double check on your calculator right now. That way you're sure that you're inputting the numbers correctly, and then compare it to my answer, and then hopefully we get the same answer. And if not, I'll double check mine like I'm doing right now. And if not, we can work on some office hours and we'll go over why didn't we get this. But we should get an answer of z being 37.14 degrees. So if I know this is 37.14, what we said before was if I get 180 and I subtract those two other angles, I'm going to get angle x. So angle x is going to be 180 minus 75 minus 37.14. We get this to be 67.86. So this angle is 67.86 degrees. Hopefully I'm not going too fast. If again I am going too fast, pause the video, rewind it, do what you got to do, and then you can rewatch part of it. Or again, work out an office hour with me so we can go over this. So now I have my angle x, and I want to find side x. So going back to my ratios over here, I just need to choose x again. Sine x over x. Actually, no. Say I made an error. I want to solve for side x, so now we can just flip the ratio. Let's put the side at the top now. So x over sine x, and that has to be equal to something else. So I just have to pick one of my ratios, either y or z. So which one would you choose in this case? Technically, you could choose either one of these. I would choose the y's, only because the y's were given to us in the question. if by some chance I did all of this and I got a wrong answer with Z, and this just, let's say I got 56 instead of 37. If I were to use this angle and this measurement then I'm going to get a wrong answer when I use it over here. So I would use Y in this case. I mean, you're going to get if you use the wrong one anyway, you might get a wrong answer, but always use the ones they give you in the question, I'd say, just to be safe. So I'm going to put Y over sine Y because I want the side lengths. So I'm going to put those on the top of the ratios. So we said Y side length is 8 over sine 75 is equal to X sine X, and we said the angle of X was 67.86 degrees. So we're going to put 67.86. So again, we put these the unknown at the top of the fraction so that when I do this now, it's just going to be sine 67.86 times 8 all over sine 75. I'm just multiplying my denominator onto this side. So then I'm just going to type all of this into my calculator. Maybe I'll zoom in a little bit. So again, all I did was I put my ratio here, I put my sides at the top, and then all I did here is I multiplied both sides by this denominator, so I get this times this over this. So I'm going to get sine 67.86, times 8, and I get that divided by sine 75. I put it in brackets just to make sure that the calculator knows to do this first and then do division. And then we get 7.67, it looks like. So the length of side X is 7.67 centimeters long. And of course I left a good word problem at the very end here. So we just have to read the question carefully and double check what they're asking, but there is a lot of algebra in here. But we're going to go over all of it, and again, if you need to pause the video, if you want some extra help with it, please let me know and we can go over it. So it says two angles in a triangle measure 59 degrees and 48 degrees. They haven't told us which letters are what because, well, pretend this diagram's on here, we'd have to do it ourselves. The shortest side of the triangle is 7 centimeters shorter than the longest side. Calculate the length of all three sides to the nearest centimeter. So I put this triangle diagram here for us, and I just labeled it A, B, and C. They actually didn't specify what the labels were, so let's just use letters we're familiar with, A, B, C. And they give us two angle measures here. They give us 59 degrees and 48 degrees. Well, based on my diagram, I have kind of a big angle and then two smaller angles. But I can figure out that third angle measure, because remember, if I know two of the angles in a triangle, I can subtract them both from 180. I'm going to zoom in, sorry, because I apologize if my writing's a little small. If I subtract all of these, I'm going to get 73 degrees. So I know the biggest angle measure is going to be 73 degrees. Then I'm going to have a smaller angle at 48 and a smaller angle at 59. So which of these three angles that I drew, and I could have drawn any triangle, but now that I know kind of the rough sizes of these, this one looks like the biggest one, so I can make this 73. I know it looks like a right angle, but again, it's not drawn to scale. We can say this is going to be 73. What's the next biggest looking angle? I would say it's this one. Again, if you pick the other one, it's fine as long as you label things correctly. And the last one is 48. I'll pick this one to be 48 degrees. It honestly shouldn't matter if you label things correctly, but try and use your best judgment of different sizes and it should work out for you. So I have these three angles now. And it says the shortest side of the triangle is 7 centimeters shorter than the longest side. So a general rule of thumb is if I have an angle here, the biggest angle will have the longest opposite side. And the same goes for the smallest. Which kind of makes sense, because when we did our primary trig ratios with right angle triangles, the hypotenuse was always the longest side, which is always opposite from the 90-degree angle. So which side here, this one, or this one, is going to be our longest side? Just by looking at it, you know that this looks to be the longest, and that is across from the biggest angle. So we're going to say that this is the longest side. And the shortest side is 7 centimeters shorter than the longest side. So let's just call the longest side x. And the shortest side should be opposite from the smallest angle. The smallest angle is 48. So this must be the shortest side. Let's say this is going to be x, but 7 centimeters shorter than x, so x minus 7. So a little bit more work to get our information here, but not out of the realm of what we're able to do. So like we were able to figure out the 73 degrees by knowing the properties of our triangles and angles and triangles. And then we're able to use what we know about angles and lengths of sides to know that we can figure out which is the longest and shortest side. And then just by following the clues in the question, we know that we have a longest side, x, and the shortest side is 7 centimeters less than that. So now let's think about our ratios here. I'm just going to write out our ratios here. I want to include the diagram too, so I'm just going to zoom out. That's why I'm trying to make this work. So luckily we used A, B, and C, so we can use our sign with A, B, and C. And I'm looking for sides, it looks like, because it says calculate the length of all 3 sides. So my ratio is going to have the lengths at the top. So A over sine A, B over sine B, C over sine C. So now based on the question, we can start filling in what we know, but let's write out what we know on the side because we used that before and I think it was helpful. So we know angle B is equal to 59 degrees. Angle A is 48 degrees. Angle C is 73 degrees. Sorry, I just set off my phone by accident. So we have our ratios. We have the sides at the top. I have my angles here, angle B, angle A, angle C. What about my side lengths? Well, side B, I don't know. Side A, we do know, x minus 7. And side C, we know is x. So I don't know what side B is. I mean, we have to find all side lengths eventually, but I don't know what B is. There's no value. There's no even variable we could solve for. So I'm not going to use ratio B in this case. I'm just going to use A and C because I can fill in everything for A and C, and I'll be able to solve for this variable. So now we're isolating for variables within our sign stuff. So it's a little bit of work, but we'll be able to do it. So I'm going to sub in what I know. Side A is x minus 7 over angle A, which we said is 48, is equal to, we said side C is x, and angle C is 73 degrees. So what I want to do now is I want to do something we call cross multiplying, where I multiply the denominators onto both sides. You can also think of it as I'm multiplying both sides by the denominators, and they'll cancel out, and all I'll be left with is sine 73 x minus 7 is equal to x times sine 48. If you have trouble with this, please book an office hour with me. It's like 5 minutes and I can make you, or help you understand it anyway. So all I did was cross multiplying, or multiplying both sides by both denominators, and then canceling out. So now I have sine 73 x minus 7 x sine 48. Remember that sine 73 and sine 48, they're still numbers. So I'm just going to treat these like distributive property. So that this side is going to equal sine 48x, and this side is going to be equal to sine 73x minus 7 times sine 73. So at this point, if you wanted to start converting to decimals, I don't blame you. I would convert all of these decimals and then just make them go to 4 decimal places though. And if you're like, Mr. Land, that's a lot of math and writing numbers that we have to do. I agree with you, and I still want you to do it. If you can, if you're comfortable, just leave them like this and then dividing at the end, you can do that too. But worst case, I'm just going to turn these into decimals. That way, it's a bit easier if we're not sure what to do. So I'm going to go to 4 decimal places, minus 6.69. Then if I turn sine 48 into a decimal, 0.7431, then x. So now we have decimals. And if you're complaining there's a lot of decimals, I mean, people complain there were fractions and you wanted to use decimals. So now we can use decimals. So hopefully we're not complaining. So how do we get the x by itself now? Well, x's are on both sides. If I want, I can throw this on this side, throw this on this side. I just want the x's on one side. So why don't I just move this to the other side? I'm going to have negative 6.69 is equal to 0.7431x minus 0.9563x. And then these are like terms because they both have x. I subtract the 2 and I end up getting negative 0.2132x. And I want to get the x by itself, so I'm going to divide by this decimal. And I want it for positive x, so I'm going to divide by the negative portion of the number, or including the negative in that number. So then I divide the 2. I'm just going to double check my work. And I get 31.38 centimeters. So after all that work of isolating, of using our sine ratio, and then isolating for the variable x, we have x, which is also, we said, side C, is equal to 31.38 centimeters. Now, I have side C. If I wanted to find side A now, well, we said A is equal to x minus 7, which is equal to 31.38 minus 7, because we said x is this number. So if I subtract those two things, or those two numbers, sorry, I get 24.38. So I have 2 of the 3 side lengths now. I have 31.38 for side C, which we said was x, and I have side A, which is 24.38. So yeah, a lot of algebra, a lot of math going on. So hopefully you remember our distributive property, isolating variables, and getting rid of fractions with our by multiplying our denominators. All right, so we have 2 of the sides now. I got to get side B now. So I'm going to have to bring ratio B back. So we're going to have B sine B, because I need to figure out which side B is, because it says calculate the length of all 3 sides. So calculate the length of all 3 sides. So I have A and C. I got to figure out what this one is. So if I look back at the things that I know now, well, I know C, I'll leave that as x, is equal to 31.38 centimeters. And I know what A is. But again, whenever I'm solving for one of the variables here, I just have to pick one of these ratios. So I'll just pick C because I already wrote it down. So let's just do side C is equal to sine angle C, which is equal to side B sine angle B. So let's fill in the things that we know. We know C is 31.38 over sine, and the angle of C we said was 73. We want to know what side B is, all over the sine of angle B, which is 59 degrees. So now to get the B by itself, I'm going to multiply both sides by this denominator, so that we get sine 59, 31.38 over sine 73. And I know I should be lining these up, but running out of space. just going to do this to kind of make sure they don't get stuck together. So if I multiply this and divide by this, I should get a value of 28.12 for the side length of B. So we can write as our therefore statement by using, so all we did here was use our sine law, and we just had to incorporate some of the values that we solved for from over here. So therefore, side A is equal to 24.38, side B is equal to 28.12, and side C is 31.38 centimeters. So these values seem like, relatively close. So like we don't have like 1,024 centimeters for one of these, or 1 centimeter. So these all kind of seem like they're in the right place, so that it seems pretty good. So here's our homework at the bottom here. Please try doing the homework, obviously, but remember, for our sine law, whatever we're solving for, we should put the top of our ratios, and I only ever need 2 of the 3 ratios in order to do sine law. But the rest of it is just isolating for variables, which we've done before. So again, if you need some extra help, please let me know. We can work out some office hours, and thanks so much for your time.